Okay, welcome to Geometry Online, Chapter 10, Section 1. We are going to start a new chapter here after our test the last time we were together. And it's one of my favorite chapters. It's not totally entirely difficult, but just a lot of great geometry themes throughout Chapter 10. And just a one-word topic in the whole chapter in the circles. So we're going to spend a whole chapter, and I was looking, almost every lesson has two parts. It's that long. There's that much to talk about. It's all about circles. So strap in. The plan will be, we'll obviously have some lessons here throughout the next couple of weeks. And right now we just have scheduled one quiz. I think as I have it set now, we'll plan to take that quiz before Friday. Right now I have it in my planner as Friday. We may bump it into early next week. But again, we'll have a couple of lessons, obviously homeworks. How the homework will work is essentially you'll just look at the assignment either on the Google Classroom homework page, homework tab, or in RenWeb, and then you'll complete on paper, take a picture of it, upload that picture to the Google Classroom, and that's how you'll turn in your homework and practice problems from these sections. Then again, just one quiz, probably Google form, still working that out, and I'll let you know in future lessons what that'll look like. But for today, it's just Section 1, and I should put Section 1A because as I mentioned before, almost every lesson here in Chapter 10 has two parts because there's a lot to talk about with circles. Obviously, some basic things that we'll get to today that you've known forever about circles, but then also, obviously, some deeper things here in 11th grade geometry that we'll look at as we explore circles. So 2 points today. The first one is identify segments. All right, and so we want to be able to know, for the most part, we know the different segments on a circle. Still keep up with your note cards. So I'm probably going to type out most of this card on the screen, but you will want to keep up and keep your note cards going. So again, I'll try to type kind of what the content will be, but you will want to do them on a note card and not just in your notes or on paper. All right, so this is note card 146, and we're going to kind of define a circle here. So let me get this in red. Okay, so a good basic definition of a circle is the set of all points in a plane equidistant. Kind of sad we can't be together for this lesson because I would already picturing or thinking in my mind what Monix would say if I said, what's a good definition of circle? And then Braden would chime in and eventually Josh or Ethan would save us and we'd get the right answer. So set of all points in a plane equidistant from a given point called the center of the circle. Now, there is a symbol for circle that you want to be familiar with, and I'm going to look and see if, oh yeah, I knew it. There it is. All right, so there's our example of what, how you could label a circle, okay? It's the, obviously a circle, but then a point inside. So that's the symbol that represents circles. So circle C would mean the center was C. Okay, so it's the set of all points in a plane equidistant, or the same distance from a given point, called the center of the circle. Underneath that main definition of circle, we have a couple subpoints, and the first one is a radius. And again, we're familiar with a lot of these already. Radius is the segment with endpoints at the center and on the circle. Okay, we will come back and we'll label these when I give you a picture that's on this note card number 146. Okay, another one that maybe we're a little less familiar with is called a chord. A chord, any ideas? It's going to be a segment. The only difference is it doesn't run through the center. So a segment with endpoints on the circle, but doesn't really have to run through the center. Now it could, but then it would be a next definition, which is a diameter. So a chord is just any segment with endpoints on the circle. Diameter is a chord that specifically passes through the center and is made up of collinear radii. Remember, the plural of radius is radii. Okay, let's get a little picture on this card as well that we can use and get some segments. So if I had on this card a circle, as such, and then again we'll call it circle C. So if I can pick my center there, and I'm going to label that as point C. All right, a radius would be an example of something that goes from the center to the side, right? And that would be your radius. So we can call this point, if we want, point D. And so back here to radius, you can write next to that in your note card, potentially in red. That would be on our example segment CD. Okay. A chord is simply a segment, but it doesn't run through the center. So be something like that, okay, where it doesn't run through the center. And we'll call that one with the endpoints there A and B. So a chord over here is any segment that pretty much spans the circle. It's called a chord if it doesn't run through the center. Again, technically a diameter is a chord. But the more specific name, once it runs through the center, of course, is a diameter. All right, so our last one here, we can call it F and G. So again, technically, we could even pencil in here, if we're talking about chords, technically we can add FG there as well, because that is also a chord, right? But that is the only diameter because that has to pass through the center. And then notice what they say about collinear radii. In other words, CG and CF we can add up here to our radius definition. CF, CG, okay, those are all radiuses. So diameter is made up of two collinear radii. All right, that is note card 145. You'll want it to look similar to that. Go and get that picture on there in blue. Should have done it in blue. I don't know if I could do that instead of black. But that is number 145. All right, and then hopefully you have your book. Obviously, you're going to have it for homework. A lot of these, typically you see sometimes even in class. We'll talk through them just because it's easier, but especially as we're doing it on the whiteboard here, sometimes it's easier to look in the book and kind of talk through and think through rather than running a lot down in our notes. So look at page 683. Okay, that's what we filled in there as far as kind of the definitions of what a circle is. So you'll see there identify segments. All right, so if I was to go down it, we do check your progress is what we would do in class. We would all look at on page 683 and I ask you, all right, name me the circle. What's the name of the circle? And you'd say circle X. Remember the symbol there is that circle with the center in there, circle X. All right, name me a chord. How many chords are there? 2. R, S, Z, T. We're on the bottom of page 683. Name me a radius. ZX, XV, XT, XU. Okay, 4 radii. And then a diameter, ZT. Remember, ZT, TZ, same thing. Okay, it doesn't matter the order there. All right, a lot of these problems are going to be a little easier. Again, we're just looking at your book, referencing those. Obviously, we'll write some out here. But for the most part, we can use our book to kind of get through some of these examples. All right, the one other thing we're going to look at today before we get into a little bit deeper concepts of a circle, so I'm going to open up another page here, is point number 2. And we're going to go over some of the basic formulas, all right, some of the basic circle formulas that you need to know. And of course, this will give us note card number 2 as well. So number 2 here, formulas in our notes. And then let's add in one more note card. And again, this is going to be number 146. Okay. All right, number 146. Here's some basic circle formulas that we'll want to know. If a circle has radius R and diameter D, following relationships are true. Okay. First one, radius. Let's get our equation here. R equals D over 2. Or we could say 1/2 D. Okay, so essentially the radius is obviously half of the diameter. Okay, so whatever your diameter is, your radius, as far as a value, is just half of that. Okay, it's just half of that diameter. So R equals D over 2, or 1/2 times D. Okay, also on this note card, let's get a formula for diameter. All right, so a good formula for diameter, I'll just type it out here, is double the radius. All right, not too hard, 2 times r. All right, and then last one, and this is the one that maybe we have a little bit, we don't necessarily have memorized unless we really jog our memory to remember it. First of all, what is circumference? Remember pi, we're going to talk a lot about this chapter because obviously it has to do with a circle. We just missed pi days on Saturday here, this past Saturday. Circumference is the distance around a circle. Okay, so pi comes from circumference divided by diameter. I believe it's C over D. So circumference is simply the distance around. So if you were to take a string or something and you were to measure, put the string around the circle and then pull the string out and measure that, that would be the circumference, the distance around the circle. Okay, and this formula uses pi, okay, essentially because of that value 3.14 that has to do with circles. So circumference is simply C equals pi d. Or we also could write it as C equals 2 pi times r. Okay, so circumference formula, C equals pi d, or C equals 2 pi r. So again, pi, where I say where it comes from, is I had it backwards? No, I had it right. Divide by diameter. So pi is circumference over diameter. So that's what's cool about pi, is that if you take any circle, and you take the circumference of it, divided by the diameter, you're always going to get 3.14159. It's crazy how that works. But essentially circumference, pi d, or 2 pi r. All right, that's note card 146. Again, just our formulas there. Switch them over a little bit. And essentially, again, radius and diameter we're more familiar with. And then circumference, most of us at least have heard those before. We just have to remember that sequence of pi d or 2 pi r. All right. Whoa, you scared me. Look who this is. I'm doing a math lesson real quick in only 3 more minutes. It's the Jaylee bug. Hi. All right, give me 2 more minutes, okay? All right. Example 2, page 684. We're going to skip over that. Pretty much, they just give you, oh, if QV, the radius is 8, what's the diameter? Oh, 16. All right, that was pretty straightforward. And then really the only other one, and I'll just type it out over here that you can put in your notes in blue, is if the radius, okay, is 2.5 centimeters, what is the circumference to the nearest tenth? Okay, so go ahead and take a minute. Hopefully you brought your calculator home. Maybe you still don't have one, but get one, and hopefully you brought your calculator home, okay? And so essentially, if the radius is 2.5, what's the circumference? Pause it and go ahead and find that answer. Okay, so hopefully you just took essentially 2 times 2.5 times pi. And then the nearest tenth, your circumference, 15.7. And 15.7 centimeters would be your circumference. All right, not hard things. If you look at this first homework, essentially you're just kind of getting familiar with circles and labels and labeling things. Really nothing too tricky. Just kind of wanted to introduce circles here in this first lesson, 10.1a, and get you some of the basic terms here as we go forward.